but. What's the caveat? Well, let's just go up here. Let's just erase our tangent line up here. It's not helping us very much for the next step. If this function flattened out, such that in this interval here, f prime is 0, flat, well, using y equals x, reflecting over y equals x, as we've done initially, 7, 10, reflect over y equals x gives us 10, 7. This reflecting over here, the inverse becomes a vertical line. Well, a vertical line simply means undefined, and we can't have that. That is something we can't have if we are dealing with derivatives, take differentiation, and so on. So the but is that f prime, the slope at some point c, we'll make that x, I think, some point x, must not be equal to 0. So we can't have here any flat lines. So if we've got a function that's doing something like this, we've got here an f prime of 0, well, we have to exclude that on our interval. So if we have an interval, we can't have an interval that includes that, we have to have an interval here. So our interval on this one, let's say our interval can go from A here, but can't come up into this area, has to sort of remain somewhere down here. Well, let's make it so it just includes where we're putting f in, x in. So there's our interval. So our closed interval. So what we can say is that on a closed interval AB, if f is differentiable, at some point x equals c, then the inverse is differentiable at x equals f of c. So if it's differentiable at x equals, if f is differentiable at x equals 3, f of 3 is 7, then inverse of f with an input of 7 is going to be differentiable here. And the slope here is the inverse. In the next video, we'll try to work through an example.